Hello friends, welcome in this video session of heat transfer subject. Today we will learn free convection or natural convection. My name is Mr. S. V. Kumbar, Assistant Professor, Sharad Institute of Technology, College of Engineering, Yadra, Ichalkaranji. So in previous video lecture we have studied forced convection. In forced convection we had used mechanical means, either fan or blower. When fan is started, air is forcefully moved over hot surface, and in this way heat transfer takes place between hot surface and air. Air receives heat energy from hot surface, it goes up, again it is replaced forcefully with the help of fan. But in natural convection, no need to use fan or blower. Air automatically flows over hot surface. So what is natural convection? When a fluid comes in contact with hot surface, it receives heat energy as soon as it comes in contact with hot surface and it becomes hot. Due to absorption of heat energy, temperature of molecule rises and their volume increases, right? And therefore the fluid molecule becomes lighter, and as it becomes lighter it goes up and it starts rising. It is replaced by heavier cold fluid. Again it receives heat energy from hot surface, again it goes up, again it is replaced by cold fluid. So this is the way of natural circulation of air, and the transfer of heat from solid surface to fluid in this manner is called as free convection or natural convection. As the fluid flows automatically, that's why it is known as free convection. Similarly, when surrounding fluid is hotter than surface, heat transfer will take place from fluid to surface. So we will see few examples here. First example, vertical hotter plate. Again we can treat it as wall also. Wall, when wall is hot because of absorption of solar radiation, so air flows automatically outside, air receives heat energy, it goes up, again it is replaced by new cold air, again it receives heat energy, it goes up. So this is nothing but natural circulation of air or natural convection current. This is the second case. Here what is the difference here? Here surface temperature is greater than surrounding temperature, but here surrounding temperature is greater than surface temperature, right? So exactly opposite phenomenon takes place. So hot fluid flows over this cold surface, it is replaced by new hot surface, and in this way natural circulation of air takes place. This is the third case, horizontal hotter cylinder, air flows over this and cooling of cylinder or sphere takes place. This is one more example, horizontal hotter plate. What is the difference between these two? Here hot plate is vertical, here hot plate is horizontal. So as it is hot, air flows automatically over this hot plate, it becomes hot and it goes up. Similarly, again these two cases are same, but it is a vertical cold plate, it is a horizontal cold plate, and convection current, formation of convection current is also different, right? Now governing equation, as we know that Q is equal to, from Newton's law of cooling, Q is equal to HA Ts minus Tf, right? So A is the area of that object, Ts is the surface temperature, Tf is the fluid temperature, and H is a function of rho g beta delta T L mu Cp K, and from dimensional analysis we get the empirical correlation as HL upon K C rho square g beta delta T L cube divided by mu square raised to A into second bracket mu Cp upon K raised to B, right? So HL upon K is nothing but Nusselt number. So Nu is equal to C, that is constant, Grashoff's number raised to A, Prandtl number raised to B. So this formula, we had studied this formula in one of the video lecture, that is different dimensionless number. This number is known as Grashoff's number, and Grashoff's number plays very important role in natural convection. rho square G beta delta T L cube divided by mu square Prandtl number raised to B. Mu Cp upon K is nothing but Prandtl's number. So Nusselt number is equal to C Grashof into Prandtl product raised to N. And this is the governing equation for natural convection. So what is the importance or physical significance of Grashof's number? So Grashof's number is equal to G beta delta T L cube rho square upon mu square, and by rearranging this we will get Grashof's number is equal to buoyancy force into inertia force upon viscous force. So Grashof's number is the ratio of product of buoyancy force into inertia force to square of viscous force acting on fluid. So Grashof's number is dependent on buoyancy force, inertia force and viscous force. So various empirical correlationships, right? So in forced convection also we had seen few empirical correlationship. So students must remember that this empirical correlationship will be provided to you in examination. So Nusselt number for vertical plate and cylinder, Nusselt number is equal to 0.56 Grashof's into Prandtl raised to 1 by 4, and this equation is valid for this condition. The product of Grashof's into Prandtl number is greater than 10 raised to 4 but less than 10 raised to 8. Similarly, if this condition occurs, this empirical correlation becomes 0.13 Grashof's into Prandtl raised to 1 by 3. For horizontal cylinder, these are the empirical correlations. For upper surface of square or cylinder plate, Nusselt number is equal to 0.54 Grashof's into Prandtl raised to 1 by 4, and this is the condition to use this empirical correlation. Similarly, if this condition occurs, product of Grashof's into Prandtl is greater than 2 into 10 raised to 7 but less than 2 into 10 raised to 10, we have to use this empirical correlation, and this empirical correlation will be provided to you in examination, right? So only student should remember L is the characteristic length, and L can be calculated by the formula A upon P, where A is the area, P is the perimeter. Beta is equal to 1 upon T mean. T mean means mean film temperature, and all the properties of fluid are taken at a mean film temperature. Now how to calculate mean film temperature? For that purpose we must know surface temperature of plate, fluid temperature, and the average of these two, that is Ts plus Tf divided by 2, is nothing but mean film temperature. So few dimensionless number that we had already studied. For conduction, Biot number is equal to HL upon K, Fourier number is equal to alpha T upon L square. For forced convection, various dimensionless number, few numbers are common in both natural as well as forced, which are Nusselt and Prandtl number. So Nusselt number is equal to HL upon K, Prandtl number is equal to mu Cp upon K, Reynolds number, which is very important in forced convection, rho VL upon mu, Piclet number, it is the product of Reynolds into Prandtl, and Stanton number is equal to Nusselt number upon Reynolds number into Prandtl. Whereas in natural convection, Grashof's number is very important, G into beta into delta T L cube divided by nu square. Rayleigh's number is equal to product of GR into PI, that is Grashof's number into Prandtl's number. If it is a mixed convection, that is velocity lies between 0.3 to 30 meter per second, we can use Grady's number, that is GZ is equal to product of Grashof's into Prandtl into D upon L. So we will solve one numerical based on this. A circular disc insulated from other side of diameter 25 cm is exposed to air at 20 degrees centigrade. If the disc is maintained at 120 degrees centigrade, estimate heat transfer rate from it when disc is kept horizontal with hot surface facing upward, disc is kept with hot surface facing downward, and disc is kept vertically. Right? Now for air at 70 degrees centigrade, what is this 70 degrees centigrade? It is the mean film temperature, that is Ts plus Tf divided by 2. 120 plus 20 divided by 2. It is the mean film temperature. At mean film temperature, properties of air are given. K is equal to 0.03. Prandtl number is 0.697. And nu is equal to, kinematic viscosity is equal to 2.076 into 10 raised to minus 6. Right? And we have to use these three empirical correlation for these three given question, right? So we have to estimate heat transfer rate Q, and for convection Q is equal to HA Ts minus Tf, right? So here, as it's a circular disc and the diameter is 25 centimeter, so area is equal to pi by 4 d square. So convert this diameter into meter. Ts is given 120, Tf is given, fluid temperature is given 20. This only H is not given, so H will be different for these three cases, and H will be calculated by knowing Nusselt number in all three cases. Nusselt number is equal to HL upon K. So here Prandtl number is directly given. Use this Prandtl number directly in all three cases. Only Grashoff's number will be different, right? So we'll see first case. Case first, horizontal plate, convection from top surface, and heat flow rate Q is equal to HA delta T. So the empirical correlation which is given to us is this: Nusselt number is equal to 0.14, Grashoff's into Prandtl raised to 0.334, where Prandtl number is directly given. So just go for Grashoff's number. Grashoff's number is equal to G beta delta T L cube divided by nu square. Here nu is given, delta T is given, G is given. Beta and L is the characteristic length which is not given. We have to find out. So beta is equal to 1 upon T mean. Mean film temperature is 70 degrees centigrade. Convert it in Kelvin. That is beta is equal to 1 upon 70 plus 273. So beta will be 0.0029, which is common in all cases, right? So only the change in characteristic length. In this case, A upon P, that is area upon perimeter. So AD is a circular disc. Its perimeter will be pi d and its area will be pi by 4 d square. So L will be equal to 0.25 upon 4, that is 0.0625. Use these two in Grashoff's number formula. Grashoff's number will be equal to 1.62 into 10 raised to 8, and put this value in given empirical correlation. We will get Nusselt number as 68.51. Once the value of Nusselt number is known to us, Nusselt number is equal to HL upon K. Use this formula and find out H, and H value will be 32.88. Once the value of H is known to us, use the formula Q is equal to HA delta T, right? So the value of H is 32.88, A is equal to pi by 4 d square, and Ts minus Tf. So in first case, Q is equal to 161 watt. Similarly, in the second case, Nusselt number is equal to 0.27 Grashoff's into Prandtl raised to 0.25. This empirical correlation is given. Again, use the same value for Prandtl number. Just there will be change in Grashoff's number, and Grashoff's number will be 1.62 into 10 raised to 8. Substitute this value in the given empirical correlation. We will get Nusselt number as 27.83, and by using this equation, H will be equal to 13.36. Use this value in given equation. We will get Q is equal to 65.6. Similarly for vertical plate. For vertical plate, the empirical correlation is different. Apply the same steps. Find out beta, find out L, substitute in given Grashoff's number equation, substitute in given empirical correlation, find out Nusselt number. After that, find out H. Use the value of H in Q is equal to H delta T. Thank you. Thank you very much.